So as we dive deeper into chapter 20, 20.5 gets into what we call the law of cosines. The law of cosines can be used to find missing angles if we're given just the sides of a triangle. That's one of its uses. So remember, there is the Pythagorean theorem, a squared plus b squared equals c squared. Remember, if this holds true, then we have a right triangle. Otherwise, we're going to have what's called the law of cosines. So there's two formulas for the law of cosines, to find the opposite side and then to find the missing angle. So this inverse cosine is going to help us find the missing angle. So the inverse cosine, and then we're going to take the inverse cosine of the adjacent squared plus the adjacent squared minus the opposite squared, divided by 2 times the adjacent times the adjacent. So let's see how we can apply this formula. Again, I kind of made it one size fit all instead of your book gives us several different formulas. I'm just trying to condense it down to one simple formula. We'll see how this takes us. So I did a little bit of algebraic manipulation to make that happen. So that's what you can do with formulas is you can redesign them to your needs. So question one says solve the triangle if A is equal to 2, B is equal to 18, and C is equal to 19. Now remember, C is going to represent the longest side. So the hypotenuse of a right triangle is the longest side. So if 2 squared plus 18 squared is equal to 19 squared, then we do have a right triangle, and then we don't have to use the law of cosines. So if I do 2 squared plus 18 squared, does that equal 19 squared? So notice how 328 does not equal 361. So this is not a right triangle. So again, as we move forward, they want us to find angle A. Now, they want us to find this angle here. So if this is the angle, then side A becomes the opposite, which in turn makes the B and C the adjacents. So that's where the drawing can help understand who's opposite and who's adjacent. So since angle A is the angle we're looking for, that makes then side A the opposite. Remember, the adjacents are the sides that make the angle. So the B and C form the angle, so they're the adjacents. So to find angle A, we're going to use the inverse cosine formula. So the inverse cosine, we're going to do the adjacent squared plus the adjacent squared minus the opposite squared. Then we're going to divide all that by 2 times the adjacent times the adjacent. So the inverse cosine, if we substitute in, the opposite was the 2, and the adjacents were the 18 and the 19. So I'm going to have then 18 squared plus the 19 squared minus the 2 squared, and that's going to be all over 2 times the adjacent times the adjacent. So that's going to be 2 times 18 times 19, and then close the parenthesis. So what we're going to do is just put this all in the calculator in one shot. So the inverse cosine, and then to make a fraction, the F1 key up here is useful. And then I could put the numerator in. And then move down, put the denominator in. And you don't have to use parentheses here. You can just put 2 times 18 times 19. It's still recognized as the denominator. So that's going to give us then this 5.36. And since it says round to 1 decimal place, that means we're going to be rounding the 3. And that 6 would say round up to the 4 then. So 5.4. So 5.4 degrees would become the answer to angle B, or angle A, I should say. Now, the next angle they want us to find is angle B. So remember, side A was 2, side B was 18, side C was 19. So if we're looking for angle B, what that means is Side B is the opposite. So the 18 becomes the opposite, which means side A, the 2, and the side C, which is the 19, become the adjacents. So this is the adjacent, and this is the adjacent. So that manipulates my formula a little bit. So knowing what angle we're looking for, that's going to dictate who's opposite and who's adjacent. Because remember, the adjacents make the angle. So opposite angle A is side A, opposite angle C is side C. So we're going to do the inverse cosine. And our formula says the adjacent squared plus the adjacent squared. So it's going to be 2 squared plus 19 squared minus the opposite squared. And then we're going to divide by 2 times the adjacent times the adjacent. So that's the 219. So if we put that into our calculator, inverse cosine, and then remember F1 is our fraction mode, gets that in there. So if I put the 2 squared in, or if you want, you can just put 4 in, plus 19 squared minus 18 squared, come down, and then 2 times 2 is 4, so that's 4 times 19. So you can do a little bit of math along the way if you like, whatever you feel comfortable with. And that would be equivalent. Hit enter, and we're going to get 57.35, or that's going to be 57.4 degrees. So angle B is going to be 57.4 degrees. Our next question is, can you find angle C? Remember, angle A plus angle B plus angle C is equal to 180 degrees. So C is going to equal 180 minus A minus B. So A we said was 5.4, so it's going to be 180 minus 5.4. And B was 57.4 minus 57.4. So we don't have to use the law of cosines a third time. Since we know two angles, we can subtract those two angles from 180 to find the missing third angle. So if I type in then 180 minus the 5.4 minus the 57.4, that'll give us the 117.2 degrees. So notice how there is a little bit of rounding that they allow us to get away with this time. So it's kind of nice. So